Welcome back to Chem with Kess. Today we'll be discussing nucleophilic addition for aldehydes and ketones, but we're talking about enamine. So let's break down what enamine stands for. So En stands for double bond. So we'll be creating a double bond somewhere, and then of course we will also have an amine in this picture. But in this particular reaction, unlike imine, enamine is always going to use a secondary amine. Now, I wrote two different structures above. So what you have is this first one that has a nitrogen that has an ethyl and one side is a methyl. Note that for the secondary amine, the sides can be different or the same. So this does not have to be symmetrical. So for, again, another reminder, the secondary structure can have two of the same groups, or they can be different. That part doesn't matter. Same thing for your ring structure. It still is considered secondary because these two carbons are connected to the nitrogen. So that's how both of them are considered secondary. For the one at the top, it would be these two carbons that create it to be secondary. When we're quickly trying to draw the answer, it is not like imine, like I stated. So let's go ahead and draw the foundational picture. Once we do that, we already know that we're going to keep our eyes focused on where the carbonyl is. Now, I want you to, just like what we did before in a sense, I don't want to give you too many steps with this one, where we had the double bonded O, I just want you to turn it to a single bond for right now. On top of that single bond is where I would want you to attach your nitrogen and whatever the two groups are connected to it. So for like the one on the bottom, it's the nitrogen and the ring structure. So really what I did was I removed the hydrogens, I removed the oxygen, and I removed one of these bonds. Okay? So that takes care of the amine portion. The enamine is always going to be created at the carbon that's next to the carbonyl. So the two carbons that we have that are next to the carbonyl are these two. In the case of the ketone, to note, so for ketones, when it's symmetrical, you'll only get one answer. However, when it's unsymmetrical, there's a possibility of you getting two answers. And we'll talk about that when we do some more problems. For the aldehyde, as you can see, the right side is just a hydrogen. So the left side is the only carbon to consider. What we're going to do then is now create a double bond for the ketone that can go either to the left or the right because it is symmetrical, but for the aldehyde structure, it must go to the left-hand side to create that enamine. So again, En stands for the double bond, and just remember that the double bond is always going to be next to the amine structure. So for the enamine's functional group, that is going to be the double bond connected to the nitrogen. This is the look of the actual enamine. Let me know if you have any questions.